motions, in fact, are very important in the study of ballistics. Okay, you know, you design what kind of guns, these things, you need to think about these parameters. Okay, you have to be able to adjust the angle and adjust the amount of the powder you use for the gun. So it will reach some particular object here. Okay, so you need to make sure it will go to the place. So that's related to the horizontal range. You need to know how to calculate the horizontal range. And sometimes the target is behind some object. So you need to make sure the maximum height here is large enough so you can pass the object in front of the target. So this is also an important parameter. Okay. Those are one, maximum height for the motion. And also, you want to study the initial angle theta naught. Okay, so different same gun, if you put it in a different angle, the range will be different. Okay, so you want to see for what angle you will get the maximum range. Okay. In fact, from the experience, people know that to get the maximum range, you should make the angle roughly 45 degrees, right? Okay. So that even in the ancient archer, they know that, okay, to fire the arrow to a very long distance, they have to point their arrow in the 45 degrees. Okay, they know this from the experience, but we are going to show from our calculation. So let's look at how can we do this kind of problem. So the key idea for the starting the 2 or 3 dimensional problem is that you can decompose the motion into x and y direction and treat the two directions separately, okay, without regarding another direction. So let's look at how can we do this. So the motion you have, so the motion, you know that the initial angle is theta naught and the initial velocity is v naught. Okay, that's only two given quantities here. And but these two quantities cannot be used directly. This means that it's useless in this form because they are not in x direction and y direction. So we have to decompose the motion into x direction and y direction. So these two will give us the initial velocity along x direction and the initial velocity along y direction. Okay. So if you have some initial velocity like this is v naught, this is theta naught. So you have to get v naught x, the initial velocity along x direction, and v naught y. Okay. Follow the standard procedure of the vector decomposition. So according to trigonometry, how to express v naught x in terms of v naught and theta naught? How would like to express it? V naught multiplied by cosine theta naught. Okay? And v naught y will be we need something else. This is a projectile motion. Okay? In fact, if starting any motion, we still need to know the information about the acceleration. And for any projectile motion, is okay. If we ignore the air resistance, so there is only one force acted on the object, the gravitational force. Right? And the gravitational force will produce an acceleration, downward acceleration with the magnitude 9.8 meters per second. Right? And please note here why the acceleration is always 9.8 is because the wave equals to mg. And the acceleration in this case equals to the force, which is wave, divided by mass. So mg divided by m equals to c. So no match what is the mass of the ball. I didn't give you the mass. Okay, it doesn't matter. The acceleration, the weight of the ball will depend on the mass. But the acceleration produced by the weight is independent of the mass. The acceleration is always downward, 9.8. Okay. So if the acceleration is downward 9.8, so the acceleration along the x direction will be, what is the acceleration along the x direction? 0, okay? Because the acceleration is downward, there is no x component. And then ay can be written as, in this case, it's written coordinates as positive x here, positive y here, the acceleration is downward, so acceleration is negative 9.8 meters per second. Okay. You just use g here. Okay, and I don't have any number, so we know g is a constant. G equals to 9.8 meters per second. And by the way, g itself is just a constant. It doesn't have a sign. Okay. So when you write down the acceleration, you have to put the sign, positive or negative, in front of the constant. G just means 9.8 meters per second squared. Any question here?
In this class, can we round it to 10 for G?
Yes, you can use 9.8 or 10, whatever. Okay, it doesn't matter. Okay, but in this problem, I will only use the symbol. I will only use G. Any question here? Now, these are some given quantities. Then, from these quantities, we should be able to calculate other kinematic quantities. Okay. Now, first quantity. What's the first quantity we calculate? The maximum height. So, maximum height is delta y. We want to calculate delta y. Okay. If you go back to check the kinematic equations, all the kinematic equations, you will see that in each of the kinematic equations, you will have each kinematic equation you will have 4 quantities. Okay. So to find any unknown quantity, use this equation to find any unknown quantity. You need to find 3 known quantities. For example, here you can look at y direction. We know the initial velocity, we know the acceleration, but we still need something else. 3 known quantities, go for the unknown quantities. So usually when you analyze the problem, you want to analyze these things to get enough information. So let's look at the first question. What is the maximum height of the ball? So this will give you one more information. We're not looking at any arbitrary height. Okay, we're not looking at this height, this height, this height, this height, this height. We're looking at the maximum height. Okay, so there is one quantity given in the question still. So maximum height. Do we know any information about maximum, the highest point? Okay. The final velocity along y direction is 0. Vy equal to 0. So please note that the velocity at this point is not 0. You still have some x direction velocity, right? And this point. But there is no y component. Because that's the turning point. If it still has some y component, it will still go upwards. It's not the highest point. And highest point, you cannot have y component. So Vy must be 0. And then of course, this one is straightforward. To find delta y, you have V naught y, Ay, Vy, you can calculate the delta y, right? The equation, you can go back to check your equation. You can use this one. Vy squared equals to V naught y squared plus 2ay delta y. And of course, the equations are given in the original form. In fact, if you go back to look at, you get the equation is V squared equals to V naught squared plus 2a delta x. This is the general equation can be applied to any direction. Here, we apply this direction to y axis. We apply this equation to the y direction. So we have to give, we have to put the subscript, y subscript carefully and change delta x to delta y. Okay. Here, one comment I would like to add is that it's a very good habit. You always keep the track of all these subscripts. What is what's your y routine. Sometimes you may feel that okay, I know what I'm doing here. I'm doing y direction, but for simplicity, I still just write the equation like this. Okay, this is not very good because we also need to solve equation along the x direction. If you don't put these subscripts carefully, sometimes you get messed up different reactions. So, now with this one, so okay, if you put the number Vy equals to 0, 0 squared. V naught y equals to V naught sine theta naught, okay, squared, plus 2ay. Ay is negative t, so 2 multiplied by negative t multiplied by delta y. So if you move this term to the left-hand side, we get 2g delta y equal to V naught squared sine theta naught squared. So delta y equals to 0. So that's the maximum height you can reach if you give the initial velocity V naught and the initial angle theta naught. You can see the dependence here. First, it's proportional to the square of initial velocity. That's reasonable. Okay, the larger the initial velocity, the higher position you can reach. It also depends on the initial angle. Okay. So it's something like this. With different angle, the highest point can be different. Okay. Now, the second one, we want to find how long was the ball in the air, so the time to finish the motion. if you want to finish the motion, please note that for this problem, we are talking about final velocity and here. Okay, so I'm thinking about the motion from the initial point, from here to here. Okay. Now, if we want to find the time for the ball in the air, we're talking about motion from here to here. Okay. So now, for the part B, we are talking about the motion from here to here instead of from here to here. So we're looking at the problem, being sure that you know the ending points for each process. Okay, depending on the question we are asked. So this part, if we write down the unknown quantity, so initial quantity will not be changed. V naught x will be V naught multiplied by cosine theta naught. V naught y will be V naught multiplied by sine theta naught. Nothing will change for the initial condition. And acceleration will not change because it's a constant at any time. So ax to 0. Ay equals to negative t. But here, please don't put this condition for part B. This is the part A. Okay. For part B, okay, if you put that condition, you are going to find the time from here to the highest point. But we are going to find the time from here to here. Okay? So, any question here? So you cannot put this. This is not true for our final point here. So what do we know about our final point? If we have some motion from the ground to the ground,
Delta y is
delta
0.
y equals to 0. Can you see that? Okay, from ground to ground, so the height difference is 0. So this is the condition for part B to characterize our ending point, a different ending point. Any question here? So of course, then you can calculate time. In those three non-convex. So you know V naught y, Ay, and delta y. We try to calculate t. Right? So we can use delta y equals to V naught y t plus 1 half Ay t squared. Okay. This is another math equation. So you put them, you get 0 equal to V naught y, which is V naught sine theta naught multiplied by t plus 1 half multiplied by negative t squared. Okay? So you can divide every term by t. So the 0 equals to V naught sine theta naught minus 1 half t. Okay. So from this you get t equals to 2 V naught sine theta naught over. So that's the time to finish the whole motion. Any question here? I divide every term by t. Okay, so that's part B. Part C. We want to find the horizontal range. Okay? If you look at expression, we already have the initial velocity, the acceleration. And now we calculated the time t for the motion from here to here. one more. You can get time from y direction. X direction and y direction, of course, shares the same time. Time is the same for any direction. So you can use this time here and go back to cancel delta x. Okay? So delta x, the standard equation, you can use this one. V naught x t plus 1 half ax t squared. Okay. And can be ax equals to 0. So the whole term goes away. So delta x equals to v naught x, that's reasonable. Horizontally, you don't have acceleration. So it's a constant velocity motion. So the distance is simply the velocity multiplied by the time. Okay. So delta x equals to v naught sine theta naught multiplied by t, which is 2v naught sine theta of cosine. V naught x is cosine. And here you have sine divided by t. Okay. Let's combine it. We get 2 v, okay, v naught squared multiplied by sine theta naught multiplied by cosine theta naught divided by t. That's delta x, a horizontal range. Okay. Now, the last question. We want to analyze the results we got here for the horizontal range delta x. We want to find out for what initial angle theta naught the delta x will reach some maximum value. Okay, if we fix initial velocity v naught, so it will depend on the horizontal range delta x will depend on theta naught. Through the two trigonometric functions, sine theta naught multiplied by cosine theta naught. V is constant. And here, it's not easy to see this reaction, but you can see some trend here. Okay, when you change your angle from like 0 to 90 degrees, okay, you increase the angle. When you increase the angle, initial angle theta naught, sine theta will increase, and cosine theta will decrease, right? From 0 degree to 90 degree, sine will go from 0 to 1, and cosine will go from 1 to 0. Right? So you can see the balance of the two will give you the maximum. Okay, and you can expect it's almost, it should be at the middle, 45 degrees. Okay. Because the 0 degree, sine will be very small. If close to 90 degrees, cosine will be very small, close to 0. So it's only at the middle you will get the maximum. But okay, if you want to get the precise number, okay, from that you can see it should be 45. But now let's look at how can we get this exactly. We can rewrite delta x as v naught squared divided by t multiplied by 2 sine theta naught and cosine theta naught. 2 sine theta naught, cosine theta naught can be simplified by using one of trigonometry identity. Okay. I think you have learned this before. If you have the trigonometric angle, say x, so 2 sine x cosine x should give you what's that? Sine 2x. Right? This is the trigonometric identity. It's always 2. So here that means delta x equals to v naught squared divided by t multiplied by sine So the maximum of delta x will come from the maximum of sine 2 theta naught. Any sine function, when the sine function will give you the maximum value. For what angle you will get the maximum value for the sine function? 90 degrees, right? Sine is, so sine 90 degrees will give you the maximum value 1, right? So that means this is 2 theta naught. So that means when 2 theta naught equals to 90 degrees, or theta naught equals to 45 degrees, you will get the maximum. Delta x maximum will be V naught squared over T. For 90 degrees, the sine function will give you 1. Okay? Any question here? So we get 45 degrees exactly. Okay, so this last part is the analysis of the function. Okay. That will be a very important technique you are going to use in the future. Okay. So it's a little bit different with part A, B, C. Here, you just do triangulation. You may be more familiar with this kind of technique. Okay, find some number or some equation. And here, you want to look at the equation result you got. And try to find is it increase, decrease, or can, when does it reach some maximum. Okay, that's sort of analysis. In fact, the calculus, for the calculus, you have another name for the analysis, mathematical analysis. So you should be able to look at your result and analyze it to get more information from this. Okay. That's a very important technique in the real life. Otherwise, if you just see some answer like this, it doesn't make much sense to other people. You have to be able to extract information from the result. Okay. Problem can always be modified to make it more complicated, okay? And that is to try to map the real life. In the real life, we may not have this equal situation. We just solve one thing, okay? Even for the ballistic, you cannot just consider this kind of ideal case. You need to think of other things. For example, the target may be in motion. You may have to hit some moving targets. Okay? So you need to consider the motion of the target. This one provides you an example. The soccer ball is hit from the ground with an initial speed of 25 meters per second and an upward angle 36.9 degrees. So here we are giving you the initial speed 25 and the initial angle 36.9. A player 6 meters away in the direction of the kick starts running to meet the ball at that instant. He runs with an average speed of 5 meters per second. So what is the horizontal distance between the player and the ball when the ball hits the ground? motion like this. Someone kicks the ball, so it will go projectile motion like this. And 60 meters away from the hitting point, someone is running to this direction. So when the ball hits the ground, this one will run to some place. We don't know exactly where it is. It may be here or here or here or here. It's just supposed to run to here. So we want to find what is the distance between the people and the landing point of the ball. So you can see this problem is related to how can you teach the moving target. Okay, here we just want to calculate. We give you the initial angle. You calculate what is the difference. But if you adjust the initial angle, you can make it exactly fit the curve people here. So here, what we have to do is that in addition to the motion of the soccer ball, we have to decompose it into x direction and y direction. We also need to analyze the motion and the relationship between the two motions. This projectile motion and this running motion. What is the relationship between them? We should identify some relationship between them. Otherwise, if they are irrelevant, you cannot solve any problem. Okay? They should share at the same time. Right? Okay. They start at the same time, and when it hits the ground, you steer. So the time for the two motions are the same. And the time, in fact, after we decompose the motion, actually we have three motions. For the ball, x direction motion. For the ball, y direction motion. And for the person, we have three x direction motion. The three motions share the same time. That's the key to solve the problem. Okay? So, the initial velocity for the ball is 25 meters per second. The angle is 36.9 degrees. So V naught x will be 25 multiplied by 4 times 36.9 degrees. V naught y will be 25 multiplied by sine 36.9 degrees. Okay. For this one, ax will be 0. Ay will be negative g. You use 10 for gravitational constant. Negative 10. This is upward reaction. And so again, if we try to effect, you can see that if we try to find the distance between the person and the landing point, so what we have to do is that we know the total distance is 60 meters. And we can try to calculate delta x here for the soccer ball. And the delta x for the person. And subtract the two distances from 60, right? So if we put this delta x 1, this is delta x 2. So the final quantity we want to find is, in fact, we try to find 60 minus delta x1 minus delta x2 equals to 1. Any question here? And now we know how to calculate delta x1, right? That's the horizontal range check if you can derive it using the same procedure. Okay? Any questions? So just follow the procedure to do that, but now you have some actual numbers. In fact, it's easy. So to find delta x, what for the board, you have to have another quantity. What's the known quantity we use there? Delta y equals to 0. From ground to ground, you don't have the height difference. So combine these three, you get, by the way, this is the calculation. This is 15. This is 25. Okay. So if you want to calculate delta x, you need first calculate time. Okay. So you need first use delta E naught y, ay, delta y to calculate. Okay, you want to calculate delta x here. To get time t, and then with t, combine with v naught x and ax, you can calculate delta x. Okay, so question? Oh, it's 20. V naught is 20, 25. V naught x is 20. Okay, so the first thing you want to use delta y equals to v naught y t plus 1 half a y t squared to calculate the time. So 0 equals to 15 t. This is negative 10 multiplied by 1 half to minus 5 t squared. So 0 equals to 15 minus 5 t. So t equals to 3 seconds. And then delta x equals to v naught x t plus 1 half ax t squared. And ax equals to 0, so this term goes away. So delta x equals to v naught x, which is 20, multiplied by the time you calculated it, 3. 60. Okay? 16 meters. So in fact, you can see this one will exactly teach the initial point of the person. If the person is not running, you can calculate it. But of course, now you can calculate it because it's running in this direction. Now, that's delta x1. And delta x2 is very easy. That's some constant velocity motion. Okay, he's running at the average velocity, what's that? 5 meters per second. So delta x2, this is delta x1. For the running distance for the person is simply 5 is the speed multiplied by the time, which is 3 seconds. Equals to 15 meters per second. Okay. So what happens is things are like this. Initially, the distance is 6 meters, and we calculate the traveling distance for the ball is 6 meters. This will be here. And but at the same time, it will run 15 meters in this direction. So the distance between the two will be 60 minus 60 minus 15 along the person is running with the constant velocity. So the second term goes away. So you get the delta x equals to the time multiplied by the velocity. Or from the average velocity, delta x, okay, average velocity, mean average equals to delta x over delta t. So of course, delta x equals to v average multiplied by delta. Don't forget this spatial case of the kinematic equation, also given by the average velocity. If you are not X-rated, then you can simply use this and find it. Any question here? Okay. So that's the problem. I hope you can do exercise similar to that one, but you can think about it. If I give you the initial velocity plus the initial angle, and I give you the initial distance, you think about, and the speed of the person, you can try to calculate with what angle the soccer can hit the person. That's a very useful calculation in practice. If you are going to start with this meeting, okay. Now, so this problem, we wouldn't have the time to finish it, so I will set up the problem and leave the actual calculation for you to finish as your homework. Okay? Okay, it says that the ball is shot from the ground into the air and falls back to the ground. At the horizontal distance of 10 meters, the velocity is given in the vector form. Okay, that's a good thing that you can give the vector form. So you can directly know the x component and y component of the velocity at that time. You don't even have to do the cosine sine calculation. Right? Do that. So at that point, what is the x velocity, horizontal velocity? See, what is the vertical velocity? Phi. Okay, so effective. Here we give you those components. We want to find what maximum height does the ball rise and what total horizontal distance does the ball travel. If you compare it with our verb beginning problem, in our very beginning problem, we kind of give you the initial velocity, and then you calculate the maximum height, delta y, and the horizontal range, delta x. Okay? And this one, in fact, the only trick is we give you the velocity and the horizontal distance of 10 meters. So I didn't give you this initial velocity and here. What I give you is suppose it's already kept 10 meters. So it should be here, right? And I give you the velocity and this point. So, and this point, v equals to 5 I cap plus 6 j cap. So you want to find the maximum height and the horizontal range for the whole motion. You still want to find delta y and delta x. So how can we solve this problem? There are different ways. The most easy way, I think, is also straightforward to think this way. Okay, we can do this. separated into two parts. First, we use this as our ending point to go back to find the initial speed. And then from here, we can just repeat our standard calculation we have. Okay. To find delta y and delta x. Okay. I think this is straightforward, right? So you just need to consider two motions. First, you consider a motion from here to here. But we go back to find the initial speed. We know the final speed. And then once you know the initial speed, you can kind of go to y delta x. So if we write down the second part, I won't touch it. It's just the same as our first example. So the second part, you can see the known quantity and unknown quantity can be identified like this. If you consider motion from here to here, this is initial, this is final. So we know the final velocity for both x component and y component. So v x and v y. Without not, we need the final velocity. So Vx equals to 5 meters per second. Vy equals to 6. Oh, sorry. 6 meters per second, 5 meters per second. So that's the x and y components of the final velocity. And if you know ax equals to 0 and ay equals to negative 10 meters per second, right? That's acceleration. Acceleration is always like that for any projectile motion. It doesn't change, it's constant. And we want to find v naught x and v naught y. Okay? And so here we need one more quantity. In fact, given. From here to here, the horizontal distance is 10 meters, right? So delta x equals to 10 meters. So from this ray, you can find time t. From this t, you can find v naught x and v naught y, right? So this is the same thing for here. So basically, the path we are going to follow is that you know ax, vx, delta x. The first thing you can calculate t. Okay. Once you have t with ax, delta x, and t, you can calculate v naught x. Also, with t, okay, combined with ay, vy, you can calculate v naught. Once you have v naught x, v naught y, you can just do the standard calculation integral to the first half. Okay, so this finish.